what multivariate analysis is and how it is different from bivariate or univariate analysis. And I'll just briefly touch upon various topics, that is regression, fact analysis, cluster analysis. I'll just briefly touch about on it because we have, entirely, 3 sessions for regression, 3 to 4 on discriminant. So this is just to give you just idea of what multivariate analysis is. So the agenda is to discuss what are variables, what is data, and how you distinguish what is univariate, what is bivariate, what is multivariate analysis. And there's something called dependence methods and interdependence method in multivariate analysis. And we'll discuss the concept of multiple regression analysis and factor analysis. Just a concept. Okay, very briefly. So the variables we have discussed. What is dependent variable? What do you understand by dependent variable?
The one is dependent on the independent variable.
Yeah, the dependent variable is dependent on independent variables. So the changes in independent variables is seen in dependent variables. So if advertisement, the quality of product, distribution channel, service, all these are independent variables that will have an effect on your dependent variable. For example, sales here. And we discussed something about latent constructs. Do you understand that latent variables क्या होते हैं? What are latent variables?
No, ma'am.
Why no? इतनी बार discuss तो किया है. Like satisfaction, job satisfaction. I have mentioned so many times, right? So this is a latent variable. This is hidden variable. You can't measure it directly. So there are various parameters. I'm not going in detail, like your salary and all those things, culture, work culture, all those things, which has a correlation with this satisfaction. So based on these parameters, your job satisfaction, it is a kind of derived variable. So it's a latent variable, it's a derived variable, which depends on various other factors or various other variables. So that is a latent variable. Other than that, there are some measurable indicators like education, employment. These are some indicators that you can measure. So this is about variable, and this we have already discussed. What do you understand by normality? Correlation. What is correlation? What is correlation?
The extent to which one variable is dependent on another variable.
Okay, extent to which one variable is related to another variable. And what is positive correlation? What is negative correlation? So correlation not extent to which, but is that if you are changing one variable, the other variable is
also. They move in the same direction, positive in positive correlation.
They'll move in same direction, whereas a variable then male equals to 1, female equals to 2, then you do coding. So that's another thing, because we'll be using more of variable this thing interchangeably. So nominal, ordinal, interval, this is also variable. These are also called variables. So what is multivariate analysis? What do you understand by multivariate analysis? So what is the difference between univariate, bivariate, and multivariate? Any idea about this? Check this variate. What is the difference between univariate, bivariate, and multivariate?
Univariate is one where only one attribute is there.
That is one attribute.
By 2.
Yeah, that is one variable. By that is 2, and multivariate is more than
1, 2.
Yeah.
More than 1.
More than 1, actually. So multiple regression means they are more than 1. Let me show you one example. Then it will be like more clear. That is 3 or more variables. Okay, so the investigation of one variable at a time is referred to as univariate analysis. Investigation of relationship between two variables is bivariate. And when you are using 3 or more variables are involved, we use multivariate analysis. So in multiple regression, there are going to be one dependent variable and more than one independent variable. So for now, just remember that there are, univariate, bivariate, and multivariate. What is the difference? It is in terms of variable that you are investigating. If you are investigating one variable, it's univariate. Let's see one example. If by using weight, we can classify a person as slim, fit, or obese, okay, by just using weight. कि अगर ठीक है, if I have, a respondent weighs say 43 kg, I'll put him in slim. If he weighs say 60, I'll put him in fit. And if he is like above 80, I'll put him in obese. Okay, so how many variables are we using?
Multivariate, 3.
No.
One.
We are using only one variable.
Weight.
Yes. We are using just one variable, that is weight. And based on just one variable, we are classifying it as slim, fit, or obese. Now I say, okay, I don't want to go just by weight, and I see that, okay, I make this assumption that weight and height, I am going to classify in these categories based on two variables, that is weight and height. Then it becomes a bivariate analysis because I'm taking how many variables now? That is weight and height.
Two
And
bivariate.
Okay, so for example, this kg weight and this height, and this person will go in say category 1, that is slim. So I'm taking two variables, this bivariate analysis. But if I'm taking more than two, that is, I decide, okay, by weight, by height, age, date of birth, all these, I'm using all these variables, and based on this, I'm going to classify it as slim, fit, obese. So what I'm doing is I'm doing a multivariate analysis. So that is what we will be doing. Okay, we'll do multivariate analysis. So, but let's check what is univariate. You must have done this before. T-test, Z-test, ये किया था?
Yes, ma'am.
Pair t-test, chi-square, and all these things. So all this is univariate. Okay, and questions can come on this also, on ANOVA and all this chi-square. So you should know what does that mean. So you can revise this. But I'm not going in detail in this. I'll discuss only multivariate and how to calculate it in SPSS, how to run that analysis. I'll do that only. So there's one more thing. Yes.
Will we get numericals on this chi-square and all, or just the theory part?
You can get a numerical on ANOVA, on chi-square. Yes.
Okay.
That can come. So just revise all your concept, whatever you have learned, Okay. So multivariate methods, there are two different ways of multivariate. So this multiple regression factor answers, all these falls in these two different categories. So two basic groups of multivariate techniques are dependence methods and interdependence methods. What is a dependence method? Dependence method is when you have a dependent variable. Okay, so do you have a dependent variable in multiple regression? In multiple regression, you have a dependent variable, say sales, and you are checking the, what are the effect of independent variable on this dependent variable. So if there is a dependent variable, then it is called dependent factor analysis, your cluster analysis, these factor and cluster, they fall in interdependence method. Whereas your multiple regression, your discriminant analysis, your ANOVA, all these, they have some dependent variable. कोई dependent variable होता है. In certain techniques, there are more than one dependent variable, but in multiple regression, there's only one dependent variable. कितने dependent variable होते हैं multiple regression में? You have just one dependent variable. There can be multiple independent variables. For example, sales is dependent on, advertisement is dependent on sales. That is a linear regression. But if I say advertisement, product quality, and service, all these are affecting my sale, that is my dependent variable. So I have multiple independent variables, but I have only one dependent variable. So the only takeaway from this slide is that the multivariate analysis can be divided into two types. One is dependence method and second is interdependence method. So when we are checking interdependence of these different variables over each other, okay, of all these variables over each other, then it is an interdependence method. But when we have one dependent variable and we are checking the dependence of all these independent variables on just one, or any one variable, that is a dependence method. It can be one, it can be more than one. So classification of multivariate techniques. So if there's one dependent variable, it's cross tabulation, multiple regression, like I discussed. But if there is, this comes in dependence technique, your multiple regression, your discriminant, all this comes under dependence technique because there is dependent variable involved. But in interdependence technique, we are checking the dependence of each of these variables among each other. So that is interdependence technique. So factor analysis and cluster analysis are interdependence technique. So now the next question arises that which multivariate techniques to use. So it depends on the measurement of scales. And this is the reason why I taught you scales before, starting this topic. So in ANOVA, what is ANOVA?
Analysis of variance.
Analysis of variance. For example, whether heavy, medium, light, and non-users of cereals, these different users of cereals differed in their preference for total cereal. तो यहाँ पर what is a categorical variable? यहाँ पर जो dependent variable है, if it is metric, and if the independent variables are categorical, then you can run ANOVA here. Okay. So we are checking how multivariate techniques are dependent on the scales that you are using. So in ANOVA, the dependent variable is going to be metric, and in ANOVA, the independent variables are going to be categorical. What are independent variables here? This example में? Categorical. Categorical कौन सा variable है? Whether heavy, medium, light, and non-users of cereals differed in their preference for total cereal. Think about it. Dependent variable क्या है यहाँ पर and independent variables क्या है? I have already given you a hint कि independent variables categorical है.
Serial is dependent.
Serial is dependent on medium, light, and heavy.
Heavy, medium, and light.
So preference, basically preference is a dependent variable which is dependent on what? That is independent variable is heavy, medium, light, non-users. ये तुम्हारी category हो गई. Heavy 1, medium 2, light 3. So these are the categories. Okay. So there is one dependent and multiple independent variable where independent variables are categorical. Okay. And the dependent variable is metric. So in regression, let's see one example of regression. Can variation in sales be explained in terms of variation in advertising expenditures? This is easy. So sales and advertising both are, sales is what? You're
Dependent on
and
advertising expenditure.
independent, and both are metric variables, aren't they? Sales कौन सा scale है हमारा?
Ratio.
Ratio.
Yes. And we know that ratio and interval are metric. Now, multiple regression. Can variation in sales be explained in terms of variation in advertising expenditure, prices, and level of distribution? So what is dependent variable is here? What is a dependent variable? Can variation
Sales.
again sales, and the metric variable that the independent variables are
Advertisement expenditure, distribution
Price.
Expenditure,
level.
prices, and level of distribution.
yes. So all these things, expenditure, price, distribution. Yes. And discriminant analysis is in terms of demographic characteristics, how do consumers who exhibit store loyalty differ from those who do not? Dependent variable क्या हुआ इसमें?
Loyalty dependent upon demographic characteristics.
So there are two categories of dependent variable, who are loyal and who are not loyal. And then there is demographic characteristics. Okay. So, and then multivariate techniques, their second is independence. Like I said, factor analysis and cluster analysis is independent. We'll talk about it. Okay. First is regression. So today we'll cover regression and factor analysis just briefly. What is regression? What do you understand by
Measures strength of the relationship between two variables.
Strength of the relationship is measured by just one, thing that is called R square. So regression is not that, but quite close. What is regression? So just see this cartoon. What is he trying to do here? He's trying to fit a line in on this scatter plot. So this scatter plot, and you are trying to fit a line. You are trying to see the linear relationship in data. That is regression. For example, okay, so let me take it one by one. When you think of regression, think prediction. So regression uses a historical relationship between an independent and a dependent variable and to predict the future values of the dependent variable. Let me give you one example here. For example, you have sales figures and advertising dollars of January. January में आपकी sales हुई this $100,000 and advertisement you did an advertisement of 5.5. ऐसे ही February, March, April, May, June, you have all these numbers with you कि कितनी sales हुई और कितना तुमने spend किया on advertisement. Now, if I have to find January, say I spend $8,000 here, तो मेरी sales क्या होगी? That is something that you can do from regression. Okay, what you are trying to do is that तुम ये data plot करोगे. What you will do is that you will plot this data and you will try to fit a line in this data. तो यहाँ तक का तो data हमारे पास था. Okay, this data we already had. But अब मुझे क्या करना है? I want to predict कि next year में मेरी क्या sales होंगी. So what I do is that यहाँ तक data already I have. इस line को ही मैं extend कर देती हूँ. So whatever linear relationship is already there in your data, you forecast, you prepare, or you make a regression equation, and then you put in the values for say this advertising dollars की मैंने उस equation में value रखी so that I could get the sales figures. So what is regression? Are you able to understand this? What is regression?
Can you please repeat it?
Okay, so what we are doing through regression is we are estimating our dependent variable. And how we are doing that is whatever past data we have. So यहाँ पर मेरे पास ये data था. I already had this data कि एक साल मैंने जनवरी में इतना advertisement dollars, for example in 2019 I spent these many dollars on advertisement और मेरी sales ये आई. This data I already have for 2019. Now for 2020, I want to check, what is going to be my sales if I spend say $8,000 on my advertisement. This I can do through regression. So regression checks for linear relationship between variables. So what I'll do is I'll plot this data कि advertisement मेरा 5.5 था और मेरा sales 100 whatever ये number था. Then I'll check, okay, 5.8 था, मेरा sales ये value था. So I'm plotting this data. ये इसी data को मैंने plot कर दिया. ये plot समझ में आ रहा है? ये क्या हुआ है? What is this? Simple graphical representation. 5.75. So around 100-110 के बीच में, 5.75, 100 and 110 के बीच में. So this is the data. I have plotted this data, and what I am seeing is कि there is some. I try to fit a straight line in this. Okay, whatever data I have, I've tried to fit a straight line in this data, and I say, okay, यहाँ तक का जो data था उसमें मैंने straight line put कर दिया, but आगे what is going to be my sales, I extend this line. समझ में आया कुछ? What we are doing in regression, just past के data से हम एक relationship लेते हैं. We try to get, form an equation, and whatever we want to know, we just feed in that information. Let me show you this.
Prediction. Simple terms.
Yeah, in simple terms, you are predicting कि past का data कैसे behave कर रहा है. They are following a straight line. Past का data is in straight line form. And उस straight line की आप equation निकालते हो, and then you can predict the future. So this is what you are doing in regression. So when you think of regression, think prediction. A regression uses a historical relationship between an independent and dependent variable to predict the future values of a dependent variable. कि okay, मेरे past के data से last year का जो data है, उससे is there any straight line that I can draw? Remember, this is a straight line. Okay, we are saying there is a straight line, linear relationship exists. That is a null hypothesis for regression. There is a linear relationship. So we are trying to fit a straight line. See this guy, he is trying to fit a straight line. Whatever data is there, if you can fit a straight line, then okay, then it is, you can do your regression. Then what you can do is that you extend that line and use regression to predict the future. That is regression. Okay. So it uses a historical relationship between an independent and dependent variable. So whatever data we took is past data. That is called historical data. Historical data ke basis pe whatever the relationship is there between independent and dependent variable, we are using that to predict the future values. Okay. So how much sales I can generate next year if I spend 7.5 advertising dollars on advertisement? That is a kind of question you can answer using regression. A regression models the past relationship between variables to predict their future behavior. As an example, imagine that your company wants to understand how past advertising expenditures have related to sales in order to make future decisions about advertising. So how much sales I can generate next year अगर मैं इस साल 7.5 advertising dollars advertisement पे spend करता हूँ, how much sales I can generate. These type of questions you can answer using regression. So there's a way of doing this, okay? Ki SPSS mein you will punch the data and how you'll go to analyze, you'll go to, you know, regression, and there are certain outputs that will come. Let me show you this assignment that I'm going to give you, or maybe we'll do it in class together. In a pre-test data on Nike were obtained from 45 respondents. These data are given in the following table. And basically there are five to six what you call variables. And you have to see whether, you know, you have to compare and check the regression on this. So basically, aapka dependent variable is loyalty, and you have awareness, attitude, preference, purchase, intention as your independent variables. And then you get some summary, okay? You get some numbers. How to do this, how to interpret this, everything I'm going to discuss, you know, when I'll be discussing this regression. We have 3 sessions allotted for regression only. And this session is just to give you an idea ki regression se kya karta hai. There is one dependent variable and there are certain independent variable. Past ke data say you are trying to find the relationship, whether there is a linear relationship that exists, and if there exists, you check, you know, through some matrix, you check, you know, about regression, whether it's significant and all, which is the most important variable. All these things you check, and then you can predict the future. This is what is done in regression. Itna samajh mein aaya? What is regression? You tell me. Kitna samajh mein aaya, so that, you know, I'll tell you whether it's enough right now or not. What do you understand by regression?
Ma'am, it basically predicts the future sales, for example, and there are independent variables. And 3 types of regression: univariate, bivariate, and multivariate.
So there are only 2 types of regression, that is linear and multiple. Linear, when you
Yes,
have
ma'am.
dependent variable is always one in regression. So linear is when you have only one independent variable, and multiple regression is when you have more than one independent variable. So that is regression. But yes, you predict the future. But how do you predict? Historical relationship kya hota hai? What is historical relationship? And what kind of relationship?
Survey of past data.
Yes, historical is past data. So you check the linear relationship in historical data. Okay, if there is really linear relationship between historic in that historical data, then you can use regression. So इसलिए हम scatter plot में ये check करते हैं कि linear relationship है या नहीं. And if there is linear relationship, we are good to go with regression. And then we extend the line. Basically, we use that same line, that is y equals to a plus bx. So this is a, this is the slope, that is b, or y equals to mx plus c. What is this? This is equation of this line, isn't it?
Yes, ma'am. Slope.
So this line. So this is c is the intercept and m is the slope, y equals to mx plus c. What does that mean? Regression model significant hai ya nahi? Kaun sa independent variable sabse zyada important hai? We'll discuss this later. But this is just to make you understand that in what scenarios we can do regression, and you use this line. You know, this is straight line, this linear relationship between dependent and independent variable. Yes. So the null hypothesis is that there is no linear relationship between x and y. Okay. So what we are trying to find is that agar linear relationship hota hai, then what we are going to do? Are we going to accept our null hypothesis or reject? Our null hypothesis.
Can you repeat?
Yeah, our null hypothesis for regression is that there is no linear relationship between x and y. So if I get that, there is linear relationship between x and y, what can I do?
We reject the null hypothesis.
We reject the null hypothesis and we say that there is a linear
Some
relationship.
relation. Yes, ma'am.
There is a linear relationship between x and y. And so we can conduct regression. Okay. So similarly, null hypothesis for ANOVA, for multiple, for discriminant. So basically you check for this linear relationship in regression, and there is dependent variable and they are independent. So there is this, because of this dependent and independent variables, we call it what you call dependence method, which we discuss here, dependence method. Okay. Now let's discuss what is factor analysis and what is interdependence method. Okay, so factor analysis. Have you ever heard of factor analysis? What is factor analysis? So factor, okay. So have you ever heard of PCA, principal component analysis, factor analysis? So these are data reduction technique, or it's called dimension reduction. Dimension reduction. So like I gave you example of job satisfaction. And I'm saying there are 20 variables. There are 20 variables that defines job satisfaction. So, salary be A1, then work culture A2, then A3, A4, A5. So, and so on. There are 20 variables. So it works on the law of parsimony, which says that if you have less data, then you can clearly, analyze it. So what we do in factor analysis is that we are reducing the number of variables. We are seeing which variables are correlating together and we try to group them. And so that we get less number of variables, so we can do our analysis. ये समझ में आया what is dimension reduction, what is factor analysis? We are trying to group the variables together. So if I have 20 variables, I try to see what is the correlation between them. Basically, I'll run a factor analysis on them and I'll group it maybe 6, 7, whatever number of factors that come in my analysis. And instead of using 20 variables, I use 6 or 7 variables. Let me show you one example here. So factor analysis is identifying dimensions. It helps in identifying product or brand attributes that consumer consider important while taking a buying decision. Okay, the example is here. So what we do here is, for example, there are 4 variables instead of 20. Let's say there are 4 variables, and I can run factor analysis on these 4 variables and can see that which variable can be grouped under depression and which variable can be grouped under anxiety. So from 4 variables, I am reducing the data, I'm reducing the dimensions. That's why it's called data reduction technique, to 2. Okay, so it can be, these 4 variables can be expressed through these 2 variables, and these are called factors. So you have to just remember that factor analysis is it's a data reduction technique. So instead of 4 or 20 variables, you are grouping it through factor analysis and you are coming down to 2 or 3 variables. That is just, you have to remember only this. So see here, we have these 5 variables. I'm not going in, analysis part, how to read this, but from these 5 variables, you zeroed down to 2 variables, and these 2 variables are actually explaining 82% of the variance. जो आपके 5 variables हैं वो सारी 100% variance बताएंगे, but you are, when you are clubbing, you are saying that okay, I'm not taking 5 variables, I'm taking just these 2 factors which can explain 82% of the variance in the data. So this is factor analysis. And you get something like component matrix, rotated component matrix. We'll discuss this later. So are you able to understand what is factor analysis? So you get something like this total variance. Let me show you this example. So like I said, यहाँ पर हमारे 5 variables थे, से यहाँ पर एक और variable हो गया. These are like 1, 2, 3, 4, 5th variable. And what I'm doing is I'm running factor analysis here, and I'm checking that, how can I group these 5 variables, and I zero down to these 2 variables. This is something that will come in your analysis. You have to just check your analysis. This will come. You have to, there are certain measures to check that what are the eigenvalues, what is this scree plot, all those things. Let me show you if I have got the scree plot also. No, I don't have. Yes. And then you see what is the percentage of variance that can be explained through these variables. So you use this total variance explained. Yeah. So here it is, rotated component matrix. So this factor, this first factor has high value of awareness. So ye awareness, attitude is maybe high. High as in I'm comparing it with second factor. Are you able to see this? Awareness of Nike has higher score in first or second. ये मेरे दो factors बने from 1 to
the first one.
The first one. So this will go in attitude towards Nike.
First one.
First. Then preference is also
Again first.
First. And purchase intention.
Second.
Loyalty is
Second.
So then you rename these factors. You say that, okay, awareness, attitude, preference, or you can rename it as attitude. This factor. And you can rename as say purchase. You can rename these factors based on, whatever variables are coming under that. So you can say that, okay, from these 5 variables, that is awareness, attitude, preference, purchase, and loyalty, we can zero down to 2 factors, and we can call these factors as awareness or attitude, and one is purchase. You have to just rename these factors based on whatever the loadings are coming. This is called loading. So कौन से फैक्टर पे किस वेरिएबल की ज्यादा लोडिंग है, दैट इज काउंटेड इन दैट फैक्टर. सो ऐसा नहीं होगा कि आपके ये जो सारे फैक्टर्स हैं, ये सारे वेरिएबल्स, this will come in this one वाला ही. It will not be counted in second. It will come in this first one, and this will come in your second factor. So that is factor analysis. Yes. So what you can do is, I'll share one video on factor analysis, but right now you have to just remember that, it is interdependence. Are you able to, see this ki dependent variable, jo dependence wala method tha, when we were talking about regression, there was one dependent variable, that is sales. But यहाँ पर it's more of interdependence. There is no dependent variable. We are just seeing the interdependence of these variables. कि ये सारे variables, ये दो variables एक साथ club हो रहे हैं और ये सारे variables एक साथ club हो रहे हैं. We are just checking the interdependence. Okay. Okay, what is correlation? I discussed this correlation. So see the correlation, you'll use this correlation table in multiple regression also. You'll use it in factor analysis also. So correlation is basically whether, whether it's positive or whether it's negative, how, the two variables are changing, basically correlated with each other. And increase in one variable leads to increase in other variable. That is positive correlation. So see, awareness of Nike and what all is correlated. You check it like this: awareness of Nike, and then with awareness of Nike is, first let's see these diagonal elements. So what is this? What does this one means? और ये one क्यों है? What is the highest correlation?
1.
Highest,
perfectly correlated.
yes, highest correlation is 1. That means perfectly correlated. If you are checking the correlation of awareness with awareness or attitude with attitude, variable, same variable का आपस में आप correlation check कर रहे हो, then it's going to be the maximum. So हमेशा आपकी diagonal elements will be 1. That is perfect correlation. So we see for values which are higher than 0.4, 0.5. Okay, and if it is higher than 0.4 or 0.5, we say that there is some correlation that exists. So let's see here. Awareness का correlation किस-किसके साथ है? If I check awareness, check this row. When I'm saying awareness, just check this row and these columns. Awareness is correlated with .5 से ज़्यादा किसमें है? Attitude towards Nike, that is this one, 0.79. Also you check
preference.
Yes, and the preference. But here you also check the significant test. Significant test is here. अगर ये 0.01, here it is 0.01. 0.01 से अगर कम है, then it is significant. Then only you will say कि okay, 0.5 से ज़्यादा है, but significant test में भी is it less than 0.01? Yes, it is. Then it is significant. So awareness is with attitude and preference. What about with purchase intention? Awareness and purchase intention ka. What is there any correlation between awareness of Nike and purchase intention for Nike?
Yes, ma'am. No, ma'am.
No. First thing is it is less than 0.5. Okay, so correlation बहुत weak hai. There is no correlation. And second thing is significance level. Check the significance level. यहाँ पर लिखा है ना, correlation is significant at the 0.01 level. तो यहाँ पर it is not less than 0.01. It's 0.846. It is not significant. Okay. And can you see any negative correlation here? No, there's no negative correlation.
When the first one, awareness.
No, in all these variables. But highest correlation, if I have to ask you what highest correlation is among which two variables? Highest and second highest. Yes. Give me highest and second highest.
Highest is 0.790 between attitude towards Nike and awareness.
Yes, attitude towards Nike. And second highest?
Second highest is that one, loyalty for Nike and purchase intention.
Yes, this one. So significant test is also 0.00, yes. And the third one is then?
Third highest.
Third highest.
0.60.
0.60.
Attitude towards Nike and preference.
Yes. Also see, these stars. So this also indicate that it is significant or not. Okay, either you can do it anyway. Yeah, ये भी देख सकते हो. You can check this thing also कि 0.01 से कम है क्या. Otherwise you can see these stars. If it is this is significant. So we'll talk more about correlations, why we check correlation in multiple regression. What is what is the problem with correlation? If a dependent variable, say if a dependent variable and an independent variable has high correlation, is it good or not? If there is a high, I'm talking about multiple regression. You are running multiple regression, okay? And then you see a high correlation between sales and advertisement. So is it a good thing or not?
It's a good thing.
It's a good thing. And if you say you had different variables, you are doing multiple regression and you have advertisement as your one independent variables and say distribution channel as your second independent variable, and if there is a high correlation between advertisement and distribution channel, then is it a good thing or not? Sales or dependent or independent variable में high correlation है, then it's a good thing. But अगर दो independent variables में, that is advertisement and distribution channel, in दो independent variables में अगर high correlation है, तो is it a good thing or not?
No, ma'am.
Okay, and why it is not? You are right, but not.
Ma'am, because if advertisement में we'll put money, then that means if they are related, then that means it will affect the distribution channel too, which shouldn't happen otherwise.
Okay, so we'll discuss this thing also, that this is the concept of multicollinearity. And there are certain parameters through which you check multicollinearity. First is you check correlation, and there are certain parameters like VIF and all. And we'll discuss कि अगर multicollinearity होती है तो क्या problem होती है, why it is bad. Okay. So yes.